Hello, criminal justice research methods. So today we're going to be talking about research design and sampling. And if we remember, we are in this area this is where we have been. We've been talking about, the first lecture was more broad and about theories and why we do research and ideas and interests and the larger big theoretical frames that sort of motivate our research. And also, like we talked about from a practitioner's perspective, programs, how effective or not effective they are, and trying to describe what the program does is also a motivation for doing research. And so we've talked about this area, and we've talked about this conceptualization and operationalization, as I said just earlier. And so now we're focused on population and sampling, and that's whom do we want to be able to draw conclusions about, like what is the bigger population we're interested in, and who will we observe for that purpose? So what's the smaller sample that we're going to look at to make generalizations about the larger population? And so the population and sampling, the conceptualization and operationalization, and this more theoretical framework and the motivation behind research are all foundations before we can even get into picking what type of research method we want to be doing, right? So these first 2-3 weeks are really foundational. So if you are struggling with understanding the concepts or the sampling or any of those things, please reach out, because it's going to be sort of hard to follow the specific types of research methods. Like I said prior, it's not possible to collect information about every person that we're interested in, right? It's tedious, it takes a lot of cost and time, it's intrusive sometimes, like we talked about, the ethical issues of doing research, it can be extractive, and it's just not realistic most of the time. And so we do this process of sampling. So we select a smaller population to observe that we can obtain data from. And the unit of analysis that we're thinking about in this situation is a sample element. So what I was talking about, if we want to make generalizations about the larger US population, then we're making generalizations about the sample element is individual US residents, right? And so when we're talking about people who are wrongfully convicted, the individual unit is people who are wrongfully convicted. And that's the unit that we're studying, that is our dependent variable, is always the sample element. And so sampling allows us to make generalizations about the dependent variable that apply to a broader sense. So an example of a sample element that's not an individual unit of an analysis would be like if we were analyzing crime prevention programs across the US, then we're looking at organizations that have specific goals. And we might not be able to survey all of them, but maybe we can survey most of them. So going back to units of analysis, we talked about this in measurement. In the first week, how do we measure things? And we're still measuring, lots of research is still measuring. There's like the independent variable measurements and the dependent variable measurements, and then the variables that are sort of interrelated into that we're trying to separate. And those are all measurements that we have to make, and measurements where we have to think about the unit of analysis and what exactly we're talking about, right? So it's important to keep in mind the sample element unit of analysis, which is the unit of analysis of your dependent variable, because that's really where you can make generalizations. Sometimes even higher level scholars will be making generalizations about larger things, but their sample doesn't necessarily ensure that they can. So you have to be really careful about the unit of analysis. So this is a review. So individuals, when we're studying police and their actions, or the demographics of police and victims and defendants, all of these sort of specific subpopulations of the criminal justice system are individuals that we're studying. Now, if we're talking about gangs or cities or counties, like more geographic areas that compose individuals, but have their own characteristics, they have their own laws, they have their own organizational structures. We're talking about units of analysis that have their own goals specifically, right? So drug treatment, prisons have goals, police departments have goals, but gangs, cities, counties, etc., those are more geographic units that we can use that are that don't necessarily have their own goals but have their own characteristics, right? And then social artifacts is talking about behavior and decision making. So if we're talking about police-citizen interactions or convictions or things that we've constructed within the criminal justice system that aren't, like your book said, you can't observe the decision itself. You have to look towards official data and official records to find your independent variable or your dependent variable. Then we're talking about social artifacts, right? So I had a little bit of, this is a good check-in point for you to think about whether or not you know and are familiar with units of analysis and which ones are sort of tripping you up. So reading this quote, compared to other immigrant receiving countries such as the UK and Canada, the US has respectively placed over 3 times as many individuals into detention and detained 11 times more immigrants on any given day. What is the unit of analysis? What are we generalizing about? So I'll give you a second. Feel free to pause the video if you want more time to think about what the unit of analysis is. So the unit of analysis is groups because we are talking about countries. The UK, Canada, and a characteristic about these countries towards detention. I know that can be confusing because we're talking about immigrants, but that is a measure for the larger detention structure of those specific countries. Okay, the next one. The number of hours new officers spent in classroom and field training was also compared. For classroom hours, the overall median for city departments was 480 hours. Campus departments' requirements averaged 420 hours. The median number of field training hours for new officers in cities was 200 hours. As the size of the population served increased, typically the number of hours required field training hours increased for both cities and campuses. What is the unit of analysis? Feel free to pause if you want to think more. It's organizations. We're talking about police departments, campus departments versus city departments, right? So we're talking about organizations and we're comparing we're talking about characteristics of specific organizations. So it's for sure organizations because we're saying, okay, this specific campus organization versus a city organization of police departments, are there characteristics that are different between them? That's the aggregate we're speaking in. We're talking about officers, but the officers are distinct in whether or not they are city versus campus police officers. Okay. So I wanted to get you guys to become familiar with abstracts. This is part of an abstract from an empirical paper that I've taken, and the nice thing about abstracts is they provide you with the topic that they're talking about. They provide you with the data source, as you see, that they're taking from. They provide you with the results and sort of maybe the implications for the results. And so oftentimes abstracts can feel a little overwhelming because there's a lot of jargon like system avoidance and a lot of words, like very technical terms, but it's because they're trying to sort of put all of the highlights of your entire paper into an abstract. So it can feel overwhelming, but if you really read them thoroughly and get a sense of them, they can also be super helpful if you're trying to look at a ton of literature. You can skim the abstracts and say, oh, this really is not applying to what I'm doing, or oh, hey, look, they are using the exact same data source that I'm looking at. Maybe they have conceptualized or operationalized this specific definition I'm looking into in a way. I'm going to look at their method section and see how they coded their data. So it's a really great resource to feel comfortable looking at abstracts, because then you have a lot more access and means. The better you get at skimming abstracts, the better you're going to be able to sort of take the highlights and the resources from other literature and incorporate it into your own research, or write better literature reviews too. So this is Sarah Brain. She's a great younger professor and scholar, and she's done a lot of cool work. She developed this sort of theoretical idea of system avoidance, right? So the title is Surveillance and System Avoidance, Criminal Justice Contact and Institutional Attachment. In this article, I introduce the concept of system avoidance, whereby individuals who have had contact with the criminal justice system avoid surveilling institutions that keep formal records. Using data from AdHealth and the NLS, I find that individuals who have been stopped by police, arrested, convicted, or incarcerated are less likely to interact with surveilling institutions, including medical, financial, labor market, and educational institutions, than their counterparts who have not had criminal justice contact. By contrast, individuals with criminal justice contact are no less likely to participate in civic or religious institutions. So, the unit of analysis is what do you think in this situation? This is a little bit of a tricky one. If you want more time, I would pause the video, but I'm going to show what the unit of analysis is. So it's individuals. She's looking at individuals and whether or not they did or did not have contact is how she's sort of conceptualizing system avoidance. So she's looking at individuals' behaviors towards these institutions, and that's sort of how she's measuring the dynamics between those individuals, is how she's measuring this larger conception. So that's how she's operationalized it. But if we look at it, what she's measuring, her granular data, is individual people. The independent variable is whether or not you've had contact with the criminal justice system or have not. And that is she's analyzing whether or not that causes individuals to act differently post-contact or no contact. So this is really cool because you can develop these larger concepts and theories about how do dynamics work and whatnot, and you can use individuals and smaller units of analysis to represent those larger theories, right? Okay, so now that we're done with that exercise, we're going to get more into probability sampling, which I talked about. So the ability for us to make generalizations about the wrongful conviction population or the individuals and how they interact with institutions who are surveilling them, that is because we're taking a smaller population from a bigger population, and we've done it in a very specific way that's representative. So each member of our sample has equal probability of being selected into the sample. So that means that the mechanism by which we're getting people needs to be random. And sometimes it's hard to do that, so there are means that researchers can do to get closer to random. And the other aspect of it that sort of pulls you in a different direction is that the population needs to be representative of the larger population. So if we have a sample that was random, but it has like no people who are super wealthy in it, and we're trying to say something about wealth and spending, right? Then we're going to be completely not aware of this whole nother stratum of like a population. And so you want your population to be representative of the larger population, because let's say that wealthy people are a large part of the population, then you're not going to be able to generalize about that specific thing, and there's going to be a complete oversight on a specific subpopulation within our sample, right? And we're already working with a smaller population, so if there's a population within that population that we can't see, we can't measure, then we're like not getting the full truth of the larger population. So there's this, it needs to be random, and it also needs to be representative. So this is an acronym that the book uses. Some other research methods courses use this acronym, and it's called EPSOM. So it's Equal Probability of Selection Method. So like this is a way that you can remember what allows us to be able to make generalizations from our sampling and our research. Because if our sampling is non-probability sampling, then we can't make generalizations about the larger population that we're interested in. So this allows us, like I sort of talked about in the beginning of lecture, to be able to be certain to a specific degree and measure our certainty about our generalizations. Otherwise, we don't know how certain we are about our data analysis. But when we have the EPSOM, when we have equal probability of selection methods, we can make generalizations. And like I said before, our generalizations are never going to be perfect. Research methods is never not have error in it, but our error is going to be something we can quantify. So we can say, oh, I think that this behavior happens with 30% more likelihood in wealthier families. Okay, I can say that with a certain degree of certainty that I can communicate. But if I don't have a probability, an equal probability of selection method, then I can't say a generalization about something. So as you see here, the population parameter is the larger population, right? It's this larger multiple populations, and we're trying to get one sample statistic about it. And we might have different sample statistics if we're looking into different demographics and how those play into the larger population. But we're making we have one sampling frame, so we're having one sort of estimate about the larger population. And that's why lots of research people replicate the sampling and data collection of prior research, because there is a low chance, but some chance due to error, that the results they got were not accurate towards the larger population. So, and a sample statistic, it allows us to be able to say this sample statistic, I could say it's accurate to this population with a certain degree of confidence, but there is still some error. Okay, so like we've been getting at and reiterating, the purpose of sampling is to get a smaller population so we can make generalizations about a larger population. And the larger population we call parameters, because we don't necessarily know what those parameters look like, but our sample statistic is getting us closer and closer to what that parameter might look like. And the key process to being able to do that is the random selection, right? And like I alluded to, if we keep sampling, if we keep replicating our studies and doing a sample, we're going to develop a lot of sample statistics. And rules of probability theory means that the more sampling that we do, the closer that we're going to get to our parameter estimate. So if we larger and larger sample, it's going to get us closer and closer to the parameter estimate of the larger population. And so I'm going to demonstrate this at this website, which is a pretty cool resource. And you can feel free to look at it yourself as well on your own time. Let me just share the screen. Let's pick percent with internet access in countries. That's a good one because my power was completely out, and that's why I am videotaping this now. So let's say we generate one sample. We look at one country, and this is the larger population that we're looking at. So there's 203 countries apparently, and this is the larger population, the parameter that we're trying to get to. This is the truth, is that there's 43% of people with internet access in these specific countries. But let's pretend we don't know that. Let's pretend we're researchers who are the first to study this and the first to measure this. And so we're going to generate one sample. And it says, so we looked at one country and aggregated, as our units of analysis, our country. We looked at one country and we measured the percentage of those individuals that had internet access, and we found that it was 46%. So let's say it was Mexico, right? So now we're going to take 10 states within Central America. Or if we did that, that would be biased. That would be geographically located next to each other. So we're not going to do that. What we're going to do is take 10 random countries that we've generated from a random list, right? And they're going to be all over the world. And so then we have these 10 estimates, and it takes us down to 40%. So it's getting us closer. 40 is closer than 46 inherently, right? And so then we're going to generate 100 samples, and we're at 42, which is closer to the 43, which is the truth. it's pretty accurate. It's pretty much the exact number that we're looking for. And now if we generate 1,000 samples, we're at 42.62. That's literally percentage points away from our actual estimate. And the nice thing about that is that oftentimes because we're not measuring biology or any of these other things, we don't need to have a super accurate, defined thing when we're talking about social sciences, because what is 43% compared to 42%? In practicality, it's not a massive difference. But if we were looking at biological markers or something more, that error is inherently more risky, right? Okay. Like I said, we're coming up with countries that are not close to each other. They're totally random. These countries are random and they vary in internet access. We also see the confidence intervals. This is measuring our error and how confident we can say that this specific unit is within a range that's close to the larger parameter. It's convention to do our confidence intervals within 95%, but technically we could do it at a different range. It's just that's what most scholars do it at. So it's okay. So this is a fun stats thing, and you can use different larger populations that they do have data on. So Hollywood movies budget. This is the larger population. They have data on this many. So if we're taking a subpopulation from a larger population, what that looks like. And you'll see that different population parameters have different distributions of the particular measurement they're interested in. So this distribution is very right-tailed and left-skewed. A lot you can say about the population, but the whole point of this is that the more samples you take, the closer you're going to get to the population, the parameter estimate that we're concerned with. So that's why it's important to take larger samples, but as we'll talk about in a second, sometimes it's hard to get a lot of people in your observations. So you sort of have to, you can use this confidence interval to determine how many estimates you need. So feel free to play with that website. And that is a demonstration of how probability theory works. The more samples that you develop for a larger population, the closer you're going to get to be accurate towards what the actual parameter estimate for the larger population is. And estimating sampling error is what we've been talking about. It's the more samples you have, the less your error is. And so there's actually statisticians have developed calculations to determine, based off of your sample size and the larger population that you're interested in, what exactly your sampling error is, so they can calculate it. And a lot of statistical methods and Stata or R will calculate it for you as well. The two key components of sampling error are confidence levels and confidence intervals. So confidence levels are percentages. They're the percent confidence that we are that a specific parameter, the true estimate of the larger population, not our sample, the larger population, is within this range that we've estimated based off of our sample. So the accuracy of our sample statistics, so if we're looking at the percentage of people who have internet access in a specific country, we said it was 42%, is the larger number that we do know. If we're sampling, we know that within 40 to 46, this range, we know the parameter estimate is in this range with 95% confidence. So we're looking at, there is error, so there is the likelihood that the sample estimate that we developed is too high or too low to the larger population, but we can quantify that error. We can communicate that error to other people. So if you have a large range of and so what exactly, how do we sample in a way that allows us to be able to communicate the error with other people and to be able to make generalizations from a sample statistic about the larger population? And that is through these 4 sampling methods. And they're all probability sampling methods. So if you're doing this in a way that is true to how these sampling methods exist, you can make generalizations about the larger parameter estimates and population that you're looking at. And so the key feature is the relationship between the sampling frame and the populations. And so there's this quasi list that we develop of all the elements of the population. So if this is the larger population parameter that we're interested in, we develop a whole list of it. And we can't necessarily go through and talk about each of those things, right? And the sampling frame is the larger list of the population parameters, and then what we actually choose to observe is our sample. So the first is the simple random sample. So if I were to want to make generalizations about Rutgers students, and I had a whole list of students that currently go to Rutgers, and then I assigned a random number to each of them, and then I used a random number generator and I asked it to give me 75% of the population, then that would be a simple random sampling. So it's when you have a list and then you are randomly selecting a certain amount of the population from that list. And you want to make sure that it's done through random number generation and not through you yourself, or random sampling allows us to be able to make generalizations about the larger population, which I've been iterating and iterating and iterating, but it's important. Then there's systematic sampling. So this is when you are you're taking 10,000 elements, it says, and then you want a sample that's smaller than that, so you do every 10th. If I had that list of students, I did every 10 students, I picked that person. And the danger with that is that there might be a reason that the list is in that specific order, right? So maybe you're looking at a list and it has some type of pattern within the list itself. If you're doing every 10th person to observe, you might be replicating a pattern that already exists in the list. So there's a difficulty with that. And so random sampling's often better than systematic sampling. And then there's stratified sampling. So if we're concerned with a larger population, but we also want to talk about, for example, lots of criminal justice scholars look at racial inequality in the criminal justice system. And so I would have a larger list and then subcategorize by race and make sure that the amount of people I'm getting in those specific races reflects the percentage of the larger population. Sometimes this happens with cities, right? If we want cities with certain populations, like not all cities are New York City that have massive amounts of people that live there. So you might stratify cities by the population that they have. So you then, if you have a list of cities, you would say most cities fall within a certain range, then you're going to want your sample to look like the larger population sample. But within the stratified sampling, there's this idea of strata. That's the variable by which you're subcategorizing your sample with. So in my example prior, it would have been race. In this example, it's the population of cities, how big they are. Then you're going to make sure that your strata are reflective. But if I'm concerned with a subpopulation that is smaller, then I might over-represent it, and that's disproportionate stratified sampling. If we want to make sure that we have like a sample for each of the different races that we're categorizing, it might not be strategic to do a simple random sample, because it might turn out that the sample that we're concerned with doesn't get chosen, and that was by random draw. So like if we're concerned about indigenous populations, Native Americans within the US, and how they show up in the criminal justice system, and we do a random sample, we might not get Native Americans because just of the smaller population size that they have. But if we want to ensure that we have enough of a sample to compare Native Americans to white Americans or Black Americans, then we're going to purposely get an over-representative sample so we can make generalizations. And specifically, disproportionate stratified sampling is when you get an over-representation of a specific subpopulation because you are concerned about that specific population and want to make generalizations about it. Okay. And then there's the multi-stage cluster sampling. And it's just an iterative process of listing and sampling and listing and sampling. And it could have one of those processes, or it could have multiple stage. And so this is when it's sort of impossible for you to develop a list of everyone in a specific population. So like the entire US population, that's hard to develop a list from. This is used when it's hard to develop an exhaustive list. So you stratify the sample by type and characteristics. Like we talked about, you identify strata and specific variables that you're concerned with, and then you select through the strata with random or systematic sampling methods like I talked about earlier. And this is different than multi-stage cluster sampling because you can combine it with stratification. So let's say that I wanted the entire US population, but I was concerned specifically with race and I didn't have a full list, so I would go first by randomly selecting states, then by randomly selecting counties within that state. Then I would go and randomly select blocks within those counties to get the specific individual people, and that's an example of multi-stage cluster sampling. And as I described, it's listing, sampling, listing, sampling. And so the National Crime Victimization Survey is an example of multi-stage stratified sampling. So they want to represent the nationwide population of persons 12 and above living in households. So that's important, living in a household. So then the way they're going to stratify things is based off of household units. And so they developed this primary sampling unit, and they, the largest of those sampling units are automatically included because there's less of them. And then the smaller ones are stratified by population, density, reported crimes, and other variables. So they have, as we talked about, these variables define the strata, how you're dividing this larger list of the sample to sample specifically from those variables based off of how you categorize and divide your own larger sampling frame. And so and then sampling and listing and sampling. So it's like they are listing larger municipalities and population densities, and then they identify and randomly select those. And then within those, they develop blocks that they're interested in, and then they randomly select those. And then within those, they identify houses, and then they randomly select those. So there's this dividing the larger sampling frame into smaller and smaller units, and then sampling those. So it's non-probability sampling is not necessarily worse than probability sampling. It's just different in that we can't make massive generalizations about the population we're interested in. It's more an exploratory study that can happen. So for example, like my BA, my thesis, for undergraduate, I interviewed police officers and people who were formerly incarcerated about their thoughts on crime theory. And so I couldn't develop my own list of all police officers. So instead, I started with my father, who's a police officer, and he referred me to other people who referred me to other people. And that's called snowball sampling. And I also had some colleagues of mine that had been formerly incarcerated, so they referred me to other people they knew who were formerly incarcerated, and it was sort of a snowball sample of one person develops into another person, and then it sort of compounds into this sample that you get by getting referred to other people from your own interviews. It was they'll find a space or events where they ask people questions and interview them, and that's an example of reliance on available subjects. And then purposive is sort of what qualitative methods do, and quota is sort of the closest to probability sampling. It is as if you have general statistics on the population of interest, but you can't necessarily develop a full sampling frame and list of those things. So instead, you have your own quota based off of your own research, and you go into a space and say that you want 10 people interviewed from this particular demographic and 10 people interviewed from that particular demographic. So you're sort of defining the sampling frame based off of prior research for yourself. So causation and time are very important in So at a minimum, we need a proper sampling frame, and then further, we need to also ensure other statistical analysis as well, and sort of types of research methods are better equipped to address causal questions, like experimental methods and quasi-experimental methods, which we will get into next week. But this is sort of a preamble to that. And so, and time can also be included in your analysis or your sampling. So, like the household survey of NCBS, they do that reoccurring. They interview those same households multiple times, and that's when you can have sort of a panel study, and there are multiple panels of that data throughout time. Sometimes you can incorporate time into, there are different ways that time gets added to sampling or analysis, and that is inherently called a longitudinal study when time is incorporated into our analysis. And you also need to consider the time order of events. So say you're having a research study about peer influences, but the peer influences you measured at time 2, and you're looking at crime and delinquency at time 1. You can't say that the peer influence caused the crime and delinquency at time 1 because it happened after. So if you're saying that, then it's a fallacy. It makes no logical sense, because in order for something to cause something else, it needs to happen first, right? And so this is really important when you're analyzing your data and working with other secondary data sources, is you need to know when things were collected and if your time order of events makes sense for the arguments that you're trying to say. Time comes up in sampling, and it also comes up in analysis as well. So observations can be stretched over a longer period. We could ask the same question at multiple points and develop a panel study. And we can look forward or backward. Like I said, I can combine all UCR data from 1990 to 2020 and look backward in time. And most of our studies that we're doing are a snapshot of a particular time period. And what that does is it doesn't allow us to understand historical context in that frame, because we're not looking at time. But often looking at just a cross-section is the most affordable way to do something. But the nice thing is that in criminal justice, there are a lot of yearly data collections that occur, so we can incorporate time and combine data sets, and that. And then there are longitudinal studies like we talked about. So trend, there's studies changes within some general population over time. So if I compiled all the UCR data and saw crime over time, that would be a trend study. Cohort is that you examine more specific populations as they change over time. So maybe there are, if you wanted to look into different, like all those studies about how millennials are different than baby boomers, like those are cohort studies. People are determined by their place in a specific time period. And then panel studies is the same set of people interviewed on multiple occasions. So if you're following a family and you want to know youth development, how children are developing and their behaviors and social activities, then that would be a panel study if you're looking at one particular person throughout the time. Summarized from the cross-sectional trend and panel. So cross-sectional is like you are taking a picture of a particular period and you have all the variables within that time period, but that's it. You don't have economic output at time 2. There's just one time. and you have all of these variables within this one time, and you're looking at one snapshot. A trend study is sort of a slideshow. Trend studies can be seen as a slideshow. So if I compiled all of UCR data from 1990 to 2000, I'm getting different snapshots across time, like the same year at a different point in a period. It's like a slideshow. So year to year, I'm getting a new slide, new data. But it's not like I have data at each time point in history, right? That would be a lot. It's I'm getting it at yearly is the unit of analysis is yearly, and so that's the slideshow timing is I get a new slide every year. Movie is the panel study. So we're watching individual people and seeing them throughout time. It's like we have a video camera watching that specific person or tapping into that specific person every year. They sort of do a follow-up interview, right? So it's like we're identifying characters. We have our characters are the people that we've sampled, and as we follow them, it's like we're developing a film of them. Time in variables in sampling can show up as retrospective or prospective. So you can ask people, in retrospective studies, you're asking people to recall their past for the purpose of being able to categorize the data into time prior, right? And there's difficulties because people have faulty memory. They're not data systems that know exactly what time happened at one point. And especially when we're looking at criminal justice, lots of people try to have an understanding of trauma and how that shows up, but that's difficult to remember, especially in traumatic incidences. So there might be some difficulty there. There's a particular research study that I'm thinking about that had that issue. It was interviewing women, I believe, in their traumatic incidences and trying to identify them, but they sort of worked around that by having a calendar there for women to think about. Or sometimes people will have multiple interviews with people who have been victimized. That way they, sometimes the first time people ask them those questions, they don't remember, but maybe it jogs their memory later and they can remember at a time more in the future when they've had some time to reflect. So there's some ways to go around that, but we do need to be upfront with the fact that people do have faulty memories and sometimes people lie, right? And for whatever reasons that may happen, especially when we're dealing with trauma. And then sometimes we're trying to analyze past records, and something that may occur is that the records are imprecise or unavailable, or we've seen, like we talked about with crime rates, sometimes over time record keeping improves and gets better, but past record keeping is not as insightful or isn't identifying things we're interested in. Record keeping changes over time, or things might be defined in different ways. Like if we're looking at a particular offense like burglary, if in 1989 the definition of burglary changed, then we need to make sure that we identify that in our research and we somehow address it or have a workaround for that issue. So incorporating time into our observations can be very beneficial because we can make generalizations that isolate and span through time, but also it can cause more further difficulties that we need to address. And then longitudinal studies that are prospective is they're sort of more long-term research projects, and some institutions do specific panel data to provide that for researchers, and if you're doing that on your own, it gets really expensive to do longitudinal studies where you're following particular people throughout time. And then an issue that also develops from that is attrition, is that sometimes People might fall out of your study. You can't reach them anymore, especially when we're dealing with criminal justice involved people. There's issues with homelessness and housing stability. And so doing longitudinal research can also present its own issues when it's prospective as well. So like we have been iterating and iterating, cause is inherently probabilistic. I can't say with defining accuracy that this caused this, because one, I don't even know if my sampling frame has some error, right? So my sample estimates have some error. So I need to be very tentative in how I say things cause other things because of that fact, but also because there are other variables that we may not be including in our analysis that may be causing the dependent variable. And so we need to be highly aware of our causal statements and know that they are within a certain probability, because they're based off of our data. There are always going to be outliers where some independent variable didn't cause a dependent variable. So it is a level of probability. And we're not dealing with laws of physics and nature where we know the sun will rise every day. Instead, we're dealing with social dynamics, and you can say with some confidence that when, and so cause is always within a probabilistic frame because our data analysis is always probabilistic as well. We are speaking within probability, we are measuring within probability, we are developing generalizations. And so we are never defining what is actual fact. There's always room for error. There's always imperfect things. There's always outliers. And so we really need to be aware of that. So it shows you two models of explanation. I don't use these terms very frequently, but the book provides them for you. So ideographic is lists the many perhaps unique considerations behind an action, and nomothetic lists the most important and fewest considerable variables. Best explain general patterns. So this is sort of like qualitative versus quantitative. Ideographic can provide a bunch of different sort of insights on one particular action, statistically complex things with the variables that we're working with, but really highlighting the key considerations and variables that are most important and how they influence the dependent variable. So the criteria for causality are three. There has to be an empirical relationship between the two variables, the independent and dependent variable. Estimate for how the two are related is zero, then there's no way that they are related, right? So there has to be empirical relationships between the two variables. So your dependent variable needs to be influenced by your independent variable. There has to be some type of arrow that goes there. And the arrow has to be a specific direction, right? So like we talked about with time, you need to be able to say that the independent variable was measured at the same time or before your dependent variable, because if not, then you can't, your temporal order doesn't make any sense. And in order for you to say that the independent variable line comes from the independent variable to the dependent variable, your time also needs to be reflecting that as well. Because if you measured your dependent variable first and then your independent variable, then the line is in reverse of what you're actually saying. And there needs to be no alternative explanations or other variables in that relationship. So that's where we control for other variables that are related to both the independent and dependent variable to identify what actually is the causal influence. How strong is it? Is it negative? Is it positive? That's often the frame we're talking in: negative, positive, and the magnitude of that relationship and that cause. And any relationship that satisfies all three of these criteria are often causal. So a cause, types of causes are, there's the necessary cause and there's sufficient cause. So necessary represents a condition that must be present. Charged doesn't necessarily equal convicted, but if you were convicted, then you had to have been charged. So that is a necessary cause. A sufficient cause is a condition that, if it's present, will pretty much guarantee that the effect will occur. So pleading guilty, you're going to be convicted. There's, in most aspects, those two come in the same vein. They're going to happen unless there's some anomaly, some weird thing that happened between you pleading guilty and being convicted, right? And so those are necessary causes and sufficient causes. So necessary is it needs to happen for something else to happen, and sufficient is that the two are likely to happen at the same time. So we talked about validity before in measurement, and most of the validity we talked about was about sort of construct validity, making sure the concepts that we're defining in a way that makes sense and measuring in a way that makes sense to the construct, that we're actually, what we have as a construct is actually represented in our measurements, that it's translated well. And validity comes also when we're making causal inferences. We're usually talking about the validity of things. And when we talk about research methods, we're also talking about the validity and strengths and disadvantages of particular research methods. So validity can be a bit confusing because we see it in the measurement side of things, and then we also see it in our generalizations and how we can say things about other things. And this will make more sense when I go through it in a second. But so scientists assess the truth of statements about cause by considering threats to validity. So threats to validity we can see as sort of the weaknesses of our research method. And so we need to be, when we're researching things, we need to be upfront about what those weaknesses are so we can sort of explain them. And so other researchers could say, oh, that's a weakness, maybe I can build upon it and address that issue in my research. And it's sort of like how you can be in conversation with other research. And if you understand validity, you can look at any empirical research and poke holes at what they're saying. And so it's a very good idea to have a grasp on it because it is sort of the nuance of the research. So just to review, this is the validity we talked about when we were talking about construct validity and measurement, and this is all internal validity. This is validity within the research question itself and how the research question gets translated into measurements, which get translated into variables, which we identify and measure, and then we do the statistical analysis to understand the relationship between them. So this validity is all about whether or not our measures make sense within the constructs that we're defining. Now, statistical conclusion validity is a broader thing, and all of the validities I'm going to talk about are a bit broader than just measurement. They're talking about the research methods themselves. And so statistical conclusion validity refers to our ability to determine whether a change in the suspected cause is statistically associated with a change in the suspected effect. So if there's a relationship between the two. So when we're doing our statistical analysis, if our statistical analysis says 0, the estimate for how these two variables interact is 0, then there is no relationship. There is no validity statistical validity. But if it says that a relationship is +1, then that means there's like this equals that. When this is there, it equals that. Maybe it's -0.5. So it's sort of looking at the estimate of how those relationships are and whether or not there is one, and statistical analysis does that. And so that's sort of why you can call it statistical conclusion validity, because statistics is how we analyze whether or not there are relationships between variables. And we can't, as the slide says, we can't know for sure if, like we talked about earlier, our sample size is really small, then we can't say with confidence. Like, the larger our sample size gets, the more confident we can speak statistically about our findings. But if we're just sampling a group of 5 people, we can't generalize about relationships, even about the averages of people's heights in that space, because we don't have a proper sampling method. Okay, so internal validity is making sure that within our study, we've identified all the variables that might influence the 2 independent and dependent variables that we're concerned with. If we haven't, then this relationship might be spurious. I mean, it might be a product of other relationships that we haven't identified with and haven't controlled for. So if there are variables that we haven't controlled for that are influencing our independent and dependent variable, then we do not have internal validity. The how we define the relationships and the relationships that we're looking at, we've not included everything that should have been included. So non-random or systemic error. And so this can be when there's some other variable that we're not measuring that's not included in the constructs that we're defining that may be affecting the variables that we're interested in. And so this is a confounding variable, is often what people call variables that influence both of the variables that we have interest in, and if we don't include it, then we're not going to see that. And then external validity is our ability to generalize our specific research findings to a larger population. And whether or not our specific study can be replicated in other areas. So it may be that our study is very context specific and that we did an experiment, but we did it with within a specific state in a specific city, and the experiment worked, but the experiment is dependent on the context in which it is in. And so that is whether or not your findings can be generalized to a larger population or to populations that are similar to yours but in different contexts, is the external validity. And then construct validity, which we talked about, which is generalizing what we observe to the real world, and then also like how the concepts that we define get measured, and if what we're talking about what we're actually talking about, or if our measurements are a bit different. So categorizing validity, there's bias that occurs, and then there's generalizability. So like we talked about, construct validity and external validity is generalizability. If I'm taking my concepts and defining them, but I can't communicate them to other people because the way I've defined them doesn't work, then I can't generalize them. I can't communicate them to other things. If my findings only apply to a particular area, then I can't generalize them. So these are the 2 validity types that are concerned with generalizability. And then internal validity are threats to systemic and non-systemic bias. So statistical conclusion validity, we can measure our bias, we can measure our error. And so that's what we're doing when we're doing statistical analysis. And we want to make sure we have enough of a sampling frame, enough N population observations to do so, or else our error is going to be massive. And then internal validity, I'm going to go back to, so categorizing validity can be categorized into two spaces. There's bias, and then there's generalizability. And bias is this spaces, there's bias, and then there's generalizability. And bias is this idea that there is certain things that we're sort of blinded to, that we have not considered regarding internal validity. And then statistical conclusion validity is that there is a internal validity and statistical conclusion validity work very much hand in hand, because if we are not defining all of the variables that might interact with our independent and dependent variable exhaustively, then we might be producing relationships that occur that are not accurate. And so our statistical conclusion validity is when we do the analysis, whether or not there is a relationship there. And our internal validity is, have we put the right inputs into our analysis that our output of the statistics of the relationships is accurate. So these are the ways that we can talk about research methods and their threats and weaknesses. And we can also talk about their strengths too. So we can say like a particular study has extremely good external validity because it's an experiment that was done in multiple spaces and the same methods were used, so it has really good external validity. Or we can say that something has really good internal validity because it included all the variables you could think about in that particular topic. Okay, so whether or not drug use causes crime is a good example of how we can think about temporal order and causation. So which comes first? It depends on our data and how we think about it. Like if we're using panel data and a lot of the people were already caught for drug use and already caught for crime, then we need to make sure that the time 1 and time 2, that if we're trying to say that drug use causes crime, that we need to have seen drug use first in our first observations and then crime in our second observation. But if we see crime first, then the temporal order messes up the causal relationship. So there are internal validity threats because there are other variables that affect both drug use and crime. So that's an example of a threat to internal validity. So if you're reading this literature and you're saying to yourself, oh, wait, but doesn't trauma affect drug use and crime, and doesn't poverty affect drug use and crime, then that might be something you're thinking, oh, well, if I can identify variables that affect both the independent and dependent variable, there's a threat to internal validity. Or if I think the study covered all the variables that affect both of these things, then they have pretty good internal validity. And then what constitutes drug use and crime? So if people are measuring drug use by self-report data, but they think that people are not reporting accurately, but that's their measure, then there's a construct validity threat. If people are measuring crime by whether or not people think about doing crime, then that's a threat to construct validity. We don't actually know that there was a crime. And so there's this idea of scientific realism because there's always this perennial debate. And perennial means like it happens every year. People get into arguments about whether or not you can say something is causal if you haven't done quantitative methods, if you haven't done an experiment. And so there's sort of these two camps of people, like some people don't think that qualitative methods has any causal claim, and then scientific realists are sort of there to say, yes, we can say things that are causal if we're speaking within a context, and we don't need to like super define causal methods in order to intervene and develop policy and programs. Because when we do develop policy and intervention programs, they're often context specific. So if we want to know how to best implement them, we need to know the context in which they are in. And so there are issues with logic that you want to be aware of when you're reading empirical papers, because it's easy to read something and say, oh, if this study found this, I can generalize about this thing. But you need to, that's why we need to be aware of our units of analysis, because that allows us to understand what we can actually make claims about. So if our unit of analysis is, in this situation, neighborhoods, those are groups. Those are geographic zones that have their own characteristics that are not hierarchically distinguished, and are sort of more spaces, right? So if there's more crime that we find in poor areas, we can't say that poor people commit more crime. We can't take a unit of analysis that is larger and then make a generalization about the individuals within it, right? Instead, it's, if we did an analysis about individuals and we did find that poor people committed more crime, then we could say that. But it's an ecological fallacy to try to make assertions about a smaller unit of analysis when we're actually looking at a larger one. Because the characteristics that we are finding are attributed to the neighborhood, not the individual. And then there's the individual fallacy, which is that anecdotal evidence can make an argument. So we can find a lot of insight based off of people's stories and how they interpret things. And a lot of qualitative interviewing is listening and whatnot, but based off of one person, we can't make a larger argument. We can provide insight and direction for where our research could go, or some themes that we want to identify in other interviews, but we can't make an argument. We can identify concepts and themes and constructs, but we can't necessarily make an argument. And then reductionism is taking an argument and making it so simple as to the fact that it's just not true, right? So saying that poor areas have more crime just because they are poor. We don't know that. There might be characteristics about those poor area structures. There's sort of nuances to all social sciences, so making hard and fast causal statements like that is very difficult to do, and so we should be aware of reductionism. Okay. So we talked about different sampling frames and how time and causality come to this in the sort of third half of this lecture. And then what we're going to get into next week is experiments, because causality is best researched through experiments, because you can really isolate and ensure internal validity and statistical validity when you're doing experiments, rather than any of the other forms of research methods. And so we covered the theoretical portion in first week. The second lecture was about conceptualization and operationalization. We've talked about population and sampling, and now we're going to move on to the choice of research methods and the specific methods and what the strengths and benefits of methods are and how to do those specific methods in the best way possible. And so we're going to go through these things pretty quickly, but I'm also looking forward to what you guys think of these. And I think that it's really important in this first week. If you feel like you didn't do too well on your first quiz, to contact me and we can go over some of the concepts and definitions, because it's really important, because we're sort of, these first 2 weeks are defining the foundation for how we talk about different types of research methods, and we're going to be applying these concepts and definitions over and over again to different types of designs.